Welcome to Colonize the Ocean podcast, where we discuss oceanic colonization, exploration, and education with your hosts Adam Jewell and Brendan Traxler.
Ever wondered if we could really live underwater?
Yeah.
Not just for a quick dive, but for days or even weeks at a time.
Yeah.
Right now, most divers,
Mm-hmm.
they can only spend so much time in the ocean.
Yeah.
It's a real time limit down there.
Oh, yeah, for sure.
And coming back up could be a huge undertaking.
Yeah.
What if all that could be totally different, though?
Well, that's exactly what we're going to be talking about today.
Perfect.
You, our listener, brought an interesting project to our attention.
Okay.
It's called Vanguard,
Okay.
and it's by a company called Deep.
Right.
And we thought it would be a great topic for a deep dive into the world of living underwater.
Absolutely.
Mm.
Yeah, so our mission today is to understand Vanguard.
Right.
What it is what Deep is
Mm.
trying to do with this whole thing.
Right.
And what it could all mean for, how we interact with the ocean.
Yeah, definitely big questions.
And we've got a great article here to help us.
Okay.
It's from February of last year,
Right.
2025.
All right.
And it's by Ethan Butler, Deep's Chief Development Officer.
Gotcha.
It goes through the whole development of Vanguard.
Perfect.
So let's jump right in.
Let's do it.
What is the Vanguard thing anyway?
So basically, Vanguard is Deep's first attempt at making an underwater habitat for people.
Okay.
But it's important to remember that right now, it's still just an engineering prototype,
Okay.
So think of it more like a really advanced testing ground,
Okay.
not something that's ready to go right now.
I see. So it's not quite ready to just drop in the ocean.
Right. Yeah, not yet.
Okay.
I mean, the article says that what they learned from Vanguard could definitely help them make habitats that are ready to be used.
Okay.
But right now, the focus is on testing and collecting data.
Okay.
Like Butler says, the main goal is to put their designs to the test in the real ocean.
Yeah, that makes sense. I mean, you can only do so many simulations, right?
Right.
But the ocean is, it's the ocean.
Exactly, the real deal.
So why go to all this trouble?
Yeah.
Why build this prototype in the first place?
Well, Deep has this core belief about engineering.
Okay.
They say that to really innovate, you have to keep trying and improving.
Yeah.
So Vanguard isn't just about showing that they can do this.
Right.
It's about learning from the process.
Okay.
By putting their design in the harsh environment of the deep ocean, they can figure out what works,
Okay.
what needs improvement, and even what needs a complete redesign.
Yeah.
It's much better to find these problems now
Yeah.
than to find them after you've already, put it all out there.
That's smart. It's like they're saying, we have a good plan on paper,
Right.
but let's see what happens when it meets reality.
Exactly.
That's a great way to approach it.
Yeah, I think so.
Now, the article goes into detail about the different stages of development for Vanguard.
Yeah, it does.
Can we break those down to
Sure.
understand how it all comes together?
Absolutely.
Okay, so what's the first step?
The first phase is what they call dry assembly. This is where they build and test the individual parts.
Okay.
Things like the wet porch, which is basically like a submersible entryway,
Okay.
and the main pressure vessel where the divers will actually live.
Right.
And all these components are being made and tested at different places around the UK.
Oh, wow. So they're starting in different places.
Yeah, they are.
Then bringing it all together.
Exactly.
Now, like a puzzle.
That's a good way to put it.
So what happens after they get all the pieces?
Well, the next big step in dry assembly is to put it all together at Deep's facility.
Okay.
Physically assemble the whole habitat on land.
Right.
This is crucial for making sure everything fits together properly and that all the systems work together.
Okay.
It's much easier to catch any problems early on when you're still on dry land.
Right, that when it's underwater.
Exactly. You don't want to be dealing with leaks or misaligned parts when you're at the bottom of the ocean.
Definitely not. So that's the foundation.
Yeah, you could say that.
Make sure everything is perfect on land before you even think about going underwater.
Right.
What's next then?
Okay, so after they finish dry assembly,
Okay.
they move on to dry testing.
Okay.
This is where they really start putting the habitat through its paces, but still on land.
Okay.
A big part of this is pressurizing the main vessel with air.
Okay, now why do they do that?
Well, think about it.
Okay.
When Vanguard is underwater, it's going to be under immense pressure from the water.
Right. Tons of pressure.
Exactly.
So they have to make sure it can handle it.
Right.
So they pressurize it with air to simulate that.
Exactly.
To make sure nothing breaks or leaks.
That's right.
So they're basically making sure it can survive the crushing force of the ocean before it even gets wet.
Yeah, basically stress testing it.
That makes a lot of sense.
Yeah, it's a critical step.
So it's past the land-based tests.
Yep.
What's the next challenge?
All right, so then we move on to dockside testing.
Okay.
This is where they start to introduce Vanguard to water, but in a very controlled way.
Okay, how do they do that?
So they start by submerging just the bottom part of the habitat while it's still attached to the dock.
Right, so they can keep an eye on it.
Exactly, and if something goes wrong,
Yeah.
they can easily fix it.
So what are they looking for at this stage?
A big focus during dockside testing is the electrical systems.
Okay.
Making sure they work properly in a wet environment. Because when you go from a dry assembly to being in the water, there's a risk of ground faults.
Right.
So they do a lot of testing to make sure everything is insulated and grounded correctly.
Yeah, to protect the divers inside.
Exactly. Safety is paramount.
And the article mentions that they gradually lower it until the water reaches the top hatch.
Right.
That seems like a pretty careful process.
It is.
Why do they do it that way?
Well, this way they can test the systems as the pressure increases.
Okay.
But they can still easily access everything from the surface.
I see.
Even when it's submerged up to the top hatch. Right.
Non-divers can still go inside
Okay.
to do more tests and, fix anything that needs fixing.
So it's all about minimizing risk,
Exactly.
moving slowly and carefully.
That's right.
Okay. So it's been tested on land.
Yep.
And in a partially submerged state.
Right.
This is it, right? The ultimate test.
You got it.
What's the final stage?
The final stage, and arguably the most important one, is underwater testing.
Okay.
This is where they detach Vanguard from the dock
Okay.
and submerge it completely to its intended depth on the seabed.
Right, the real deal.
Exactly. This is where it's meant to be.
And how do they handle things like air and power and water?
Well, at this point, all the essential life support systems,
Okay.
things like air power, potable water,
Right.
even waste management and communication,
Okay.
all of that is provided from a surface support structure,
Okay.
which could be like a dedicated buoy or a support vessel.
Gotcha.
And this surface support allows them to monitor everything that's happening inside the habitat.
And intervene if something goes wrong.
So it's like a safety net.
Yeah, exactly.
So it's operating on its own down there.
Right.
But with a lifeline to the surface.
Exactly.
I see. And what's the main goal of this underwater testing phase?
Well, Butler emphasizes that this is where they gather the most valuable data.
Okay.
The real-world experience of diverse living and working inside Vanguard for extended periods.
Right.
This feedback from the aquanauts will be super important,
Okay.
not just for improving Vanguard itself,
Right.
but also for the design of their next bigger habitat system called Sentinel.
Okay.
So Vanguard is really a stepping stone,
I see.
a way to learn and improve for the future.
So it's not just about Vanguard itself.
Right.
It's about what comes next.
Exactly.
What they learn from this.
Right.
They're going to apply to even bigger and better things.
That's the plan.
That's pretty amazing.
Yeah, it is.
So what would Deep consider a success for this Vanguard project?
Yeah.
What are they hoping to achieve?
Okay, so first of all, the article says that just deploying and testing Vanguard will give them a ton of practical knowledge,
Okay.
about designing, building, and operating an underwater habitat.
Right.
That kind of hands-on experience is priceless.
You can't learn that from a simulation.
Nope.
You got to be there
Exactly.
doing it.
Right.
Okay, so that's the immediate benefit.
Right.
But what about the bigger picture?
Okay, well, beyond the practical know-how,
Yeah.
Butler says that just having Vanguard out there
Yeah.
makes a big statement to the world.
Right.
He says they don't know of any other habitats like this
Really?
that are currently in use or even being developed.
Wow.
So a fully functional prototype
Yeah.
that's actually generating real data
Yeah.
shows everyone what's possible right now.
Wow.
And it puts Deep at the forefront of underwater innovation.
They're leading the way.
Exactly.
That's pretty cool.
Yeah, it is.
So they're setting a new standard.
Right.
But what's the main driving force behind all of this?
Yeah.
Why are they so focused on building underwater habitats?
The article's pretty clear about that.
Okay.
They want to dramatically reduce the time it takes divers to do their work underwater.
Okay.
And the main advantage of having a habitat like Vanguard
Yeah.
is that divers can stay underwater for much longer periods,
Right.
and they only need to decompress once
Yeah.
at the end of the whole mission.
At the very end.
Right?
That's huge.
Yeah, it changes everything.
I mean, right now they have to go up and down and decompress all the time.
Yeah.
It takes so much time away from actually doing the work.
That's right.
So with Vanguard, they can just stay down there and work.
Exactly. And that's what they're aiming for.
That's amazing.
Yeah.
Can you give an example of how that would work?
Sure.
Okay.
Butler says that some missions that currently take weeks to complete,
Okay.
with all the trips back and forth to the surface and all the decompression,
Yeah.
those missions could potentially be done in just a few days with a habitat like Vanguard.
Wow, so that's like a 10-fold increase in efficiency.
Pretty much.
That's incredible.
It is.
And I imagine that would save a lot of money, too.
Oh, yeah, absolutely.
Especially when you think about the cost of running a support vessel for weeks on end.
Exactly. Vessel time is expensive.
Super expensive.
And not just the money.
Yeah.
But think about the weather.
Okay.
It's much easier to predict the weather for 3 days than
Yeah.
it is for 6 weeks.
That's a really good point.
So by shortening the mission time,
Yeah.
they reduce the risk of the weather messing things up.
Right. So a shorter operational window makes everything more predictable
Right.
and less vulnerable to outside factors.
Exactly.
And it sounds like Deep has even bigger goals in mind.
They definitely do.
What do they see as the ultimate potential for this technology?
Well, the article ends by saying that there are countless discoveries waiting to be made in the ocean,
Okay.
and they believe that Vanguard is a key step towards making those discoveries. They see this as an important step towards making humans aquatic,
Wow.
which is a pretty ambitious goal.
It really is.
But it's exciting, too.
It is. It's like a whole new frontier opening up.
Exactly.
They're leading the way.
That's right.
Oh, and the article also encourages people to follow their progress on LinkedIn.
Yeah, that's a good point.
So if you want to keep up with the latest developments with Vanguard,
Yeah,
that's the place to go.
definitely.
So to recap our deep dive today,
Okay.
we learned about Vanguard,
Right?
Deep's underwater habitat prototype,
Yeah.
which is currently undergoing this really rigorous testing process.
Yeah, multi-stage testing.
From assembly on land to testing in the water
Yep.
to full underwater deployment.
The whole 9 yards.
And the main goal of all this is to get real-world experience
Right.
and feedback from divers
Real user feedback.
so they can build even better habitats in the future,
Exactly.
ultimately leading to much more efficient and longer underwater missions.
That's the plan.
It was really interesting to learn about all the engineering challenges
Yeah.
and the innovative solutions they're coming up with.
Absolutely.
Makes you think, doesn't it,
It does.
about the future of underwater exploration
Yeah. What will it look like?
and what it will mean for our relationship with the ocean.
Big questions.
It really is a glimpse into a potential future.
Yeah, and it's exciting to think about.
It is. Thanks for taking this deep dive with us today.
It was my pleasure.